This video covers the hematological indices. The first one is red blood cell count. What's normal for men is 4.3 to 5.9 times 10 to the 6th, while for females is a little bit lower, 3.5, but still to 5.9 times 10 to the 6th. Red blood cell count decreases with hemorrhages, hemolysis, the breakdown of red blood cells, or marrow failure. It is not a sensitive test for iron, B12, or folate deficiency. Red blood cells break down naturally and are retrieved by the spleen, but when red blood cells break down too quickly, it requires the bone marrow to make more. This happens with immune reactions, infections, hemodialysis, and the result is hemolytic anemia. Hemoglobin is iron-containing oxygen transporter inside the red blood cell. Hemoglobin is the amount of red blood cell. The normal for men is 14 to 18 grams per deciliter, while females is 12 to 16 grams per deciliter. Hemoglobin increases with dehydration, while decreasing with iron deficiency anemia, malnutrition, and hemorrhage. Hemoglobin picks up oxygen from the lungs and transports it to the cells and carries CO2 back to be exhaled. Hematocrit for males is 42 to 52%, while females is 37 to 47%. Just like hemoglobin, hematocrit increases with dehydration and decreases with iron deficiency anemia and malnutrition. Hematocrit measures the percentage of red blood cells in the total blood volume, and 3 times the hemoglobin equals the hematocrit. The mean corpuscular volume is the size of a red blood cell. If there are big cells and it's greater than 90, then it's a big cell. If it's less than 80, there are small cells. And normal is 80 to 99 FLs or femtoliters. MCV decreases with advanced iron deficiency, chronic blood loss, or lead poisoning, while it increases with folate or B12 deficiency. MCV is a measure of the size of a single red blood cell. If there is low MCV, this indicates microcytic red blood cells. If there's high MCV, this indicates macrocytic red blood cells. So low MCV, microcytic red blood cells. High MCV, macrocytic. Low microcytic, which means small. High macrocytic, which means large. Mean corpuscular hemoglobin, or MCH, the normal is 27 to 31 pGs. MCH is a measure of the average weight of hemoglobin within the red blood cells. MCH is increased with macrocytic cells. So if it's a bigger cell, the weight of hemoglobin is going to be bigger, and it is decreased with microcytic cells, meaning if it is a smaller cell, the weight of hemoglobin is going to be smaller. It is decreased with advanced iron deficiency, chronic blood loss, and lead poisoning. If red blood cells are large, it's macrocytic, which is high MCV. If there's a high weight of red blood cells, there's a high MCH. Mean cell hemoglobin concentration, the average is 31 to 36 grams per deciliter. If it's less than 31, that means that the cell is pale because the MCHC is the color of the red blood cell. And this color is based on how much hemoglobin there is, or the hemoglobin concentration. If MCHC is low, you have hypochromic pale cells, which often happens in iron deficiency anemia. Hypochromic cells appear pale compared to normal red blood cells. Hyperchromia is not possible because hemoglobin saturation is limited, so you cannot have more than 37 grams per deciliter. Total iron binding capacity, or TIBC. The normal is 270 to 400 milligrams per deciliter. TIBC increases with iron deficiency and decreases with megaloblastic anemia, hemolytic anemias, and acute and chronic inflammation. TIBC depends on the number of free binding sites on transferrin. If iron is low, then there is more capacity to bind. So if you have iron deficiency, iron is low, TIBC increases because there is more free spaces for it to bind. Now we have a chart here that is also in the notes that goes through the different deficiencies, microcytic, macrocytic, and normocytic, and the different hematological indices. First we start with red blood cells. They are normal with iron deficiency or microcytic anemia because iron does not affect the number of red blood cells. Red blood cells are low when you have B12 or folate deficiency or macrocytic because there's an increased size in red blood cells, which lowers the number because they're bigger. When you have anemia of chronic disease, you have red blood cell breakdown, so the red blood cells are going to be low. With hemoglobin, you are going to have low hemoglobin with iron deficiency or microcytic anemia because when iron is low, there's not as much hemoglobin to transport the iron, and smaller red blood cells is less hemoglobin. Now you can have low hemoglobin with macrocytic because when the red blood cells are large, there's not as much hemoglobin that is needed. And when you have chronic disease, you have lower red blood cells, which decrease the hemoglobin. Hematocrit is low with iron deficiency or microcytic anemia because red blood cells are small and they take up lower amounts of the blood. When you have B12 or folate deficiency, when there's anemia of chronic disease, you have less red blood cells, which decreases the percentage of red blood cells in the total blood volume. MCV is low with iron deficiency anemia because of microcytic is small, smaller red blood cells is lower MCV. When you have macrocytic, you have larger red blood cells, and so that's a higher MCV. The size of the red blood cell does not change with anemia of chronic disease. MCH is low with iron deficiency anemia because it's micro, small, meaning less weight of the hemoglobin, so MCH decreases. Macrocytic has larger red blood cells, more weight, higher MCH. Anemia of chronic disease does not change the weight of one red blood cell. MCH, if small, then low hemoglobin, low color, which decreases MCHC. The color cannot increase, so with B12 folate deficiency, it can be normal along with anemia of chronic disease. TIBC, if iron deficiency microcytic anemia, the iron is low, then binding capacity increases because spaces are open to bind. Next, we have another chart of the different anemias, the types of anemia, and the nutritional factor needed. With megaloblastic anemia, you have megaloblastic macrocytic needs folic acid or B12. With pernicious anemia, that is only macrocytic and needs B12, as opposed to megaloblastic, which can have folic acid or B12. Iron deficiency anemia is microcytic and requires iron. Anemia of chronic disease could be normocytic and it requires protein.